morning, dear children. So today let us start the topic Bayes theorem from probability, from the chapter probability. Bayes theorem. Write as a heading Bayes theorem. So before moving to this Bayes theorem, there are some basic terms. The first one is partition of a sample space. Partition of a sample space. Is the audio and video clear? Okay, so partition of a sample space. The events E1, E2, etc. En represent a partition of the sample space S if they are pairwise disjoint. Exhaustive, and have non-zero probabilities. And have non-zero probabilities. So you know that the sample space S is the set of all possible outcomes of a random experiment, and events are subsets of the sample space. Event E1, E2, etc. En means they are subsets of the sample space S. So a set of events E1, E2, etc. En is said to form a partition of the sample space if they are pairwise disjoint. Pairwise disjoint means if we consider them as pairs, E1 and E2, their intersection will be a null set. E1 and E2 are disjoint sets. Similarly, if we consider E1 and E3, then E1 intersection E3 is null set, E2 intersection E3 is a null set. So if we consider any pair from this, they must be disjoint sets. That is, they are pairwise disjoint. Okay, the second part of this is exhaustive. Exhaustive means the union of all this, E1 union, E2 union, etc. union, En is equal to the sample space itself. Exhaustive means the union of all these subsets E1, E2, etc. En it forms the sample space and have non-zero probabilities. Non-zero probabilities means probability of any EI, E1, E2, E3, etc. En, whichever event you are considering here, that must be greater than 0. Non-zero, having non-zero probability. Probability of A is greater than 0. If these three conditions are satisfied, then we say that the set of events E1, E2, etc. En form a partition of the sample space S. Is it clear? See once again, sample space S means it is the set of all possible outcomes of a random experiment. Events means they are subsets of the sample space. So a set of subsets E1, E2, etc. En are said to form a partition of S if they have to satisfy some conditions, and the conditions are they are pairwise disjoint. That means if we consider any pair, their intersection must be a null set. And then the second one is exhaustive. Exhaustive means the union of all this gives the sample space itself. And the third one is the probability of every event is greater than 0. Having non-zero probability. So this is the first term here, partition of a sample space. Now the second one, theorem of total probability. Theorem of total probability. Theorem of total probability. Let E1, E2, etc. En be a partition of the sample space S. Be a partition of the sample space S. Partition of the sample space S, and let A be any event associated with S. Any event associated with S. Any event associated with S. Then probability of the event A is equal to probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus etc. plus probability of En into probability of A given En. This is the theorem of total probability. See now, E1, E2, etc. En be a partition of the sample space S. Partition means you know that E1 intersection E2, E1 intersection E3. If we consider any pair from this, they are disjoint sets, then the union of all these n events gives the sample space itself, and then the probability of each of these events is greater than 0. So this forms a partition, and let A be any other event, any event other than this E1, E2, etc. n, not this one. A be any event associated with S, then the probability of the event A is given by probability of E1 into A given E1 plus probability of E2 into A given E2 plus etc. plus probability of En into probability of A given En. This is the theorem of total probability. You can write this as, this sum as sigma, this is equal to sigma I equals 1 to n probability of Ei into probability of A given Ei. Probability of Ei into probability of A given Ei. So this is the theorem of total probability. Let us consider an example. You can write the question. An urn contains 5 red and 5 black balls. A ball is drawn at random. Its color is noted and is returned to the urn. Moreover, 2 additional balls of the color drawn are put in the urn, and then a ball is drawn at random. What is the probability that the second ball is red? Okay, this is the first question from exercise 13.3. So read the question well. An urn contains 5 red and 5 black balls. 5 red and 5 black balls. A ball is drawn at random. So the first thing is a ball is drawn at random. Then its color is noted and is returned to the urn, and it is placed back to the urn. And in addition to this, 2 additional balls of the color drawn are put in the urn, and then a ball is drawn at random. Second time again another ball is taken after placing 2 additional balls of the first color. Okay, first one is a ball is drawn at random, its color is noted and is returned to the urn along with 2 balls of the same color. So, probability of drawing first ball. So there are 2 possibilities. The first ball may be a red ball or that may be a black ball. So what is the probability of getting a red ball? Probability of getting a red ball. See here, 5 red balls and 5 black balls are there. So while taking a ball at random from this, what is the probability of getting a red ball? The basic definition, number of favorable outcomes by total number of outcomes. That's what we are considering here. So to get the probability of red ball, number of red balls divided by total number of balls in the urn. It is 5 by 10 or which is equal to 1 by 2. Right? 5 by 10 which is equal to 1 by 2. So this is the first case. If the first ball is a red ball, its probability is 1 by 2. What is the probability of getting a black ball? That also equal to 1 by 2, that is 5 by 10 which is equal to 1 by 2. Here 5 black balls, 5 divided by total number of balls is 5 plus 5, it is 10, so which is equal to 1 by 2. So the first part of the experiment is over now. Okay, the first part is a ball is drawn at random. And now its color is noted and it is returned to the urn along with 2 additional balls of the same color. So if the first ball is red, 2 more red balls are placed in the urn. Is it clear? Okay, then what about the number of red balls? Number of red ball becomes 7 red and 5 black. Okay, then in the urn there are 7 red balls and 5 black balls. Okay, now the second possibility is if the first ball is a black ball. If the first ball is a black ball, then the number of balls becomes 5 red and 7 black. Okay. If the first ball is black, then 2 more black balls are placed and in the urn there are 5 red and 7 black balls. So here we have to consider this as E1, this as E1 and this as E2. Okay, if the first ball is red, that is the first event, and if the first ball is black, it is to be taken as the second event E2. And you know that probability of E1 is 1 by 2 and probability of E2 is equal to 1 by 2. Probability of E2 is equal to 1 by 2. Now we have to get the event A. You have to write the event A from the question. See now, two additional balls of the color are drawn. Color drawn are put in the urn and then a ball is drawn at random. That is, a second ball is taken from the urn. What is the probability that the second ball is red? So the event A is the second ball is red. This is the event A. Second ball is red. We have to find probability of A. See now, probability of, now we have to find one more, probability of A, that is the second ball is red when the first ball is red. So two cases are there. If the first ball is red, we can choose the second one also as red. So this is the case. What is the probability of A given E1? That is probability of getting a red ball in the second row when the first ball is also a red. What is this probability? A given E1. Probability of getting a red ball when the first ball is a red ball. When the first ball is red, the urn contains 7 red and 5 balls. So what is the probability of getting a red ball from this? It is 7 by 12. Okay, total 12 balls are here and out of that 7 red are there. So getting a red ball is 7 out of 12. Now what is the second case? Probability of A given E2. Probability of A given E2 means probability of getting a red ball when the first ball is black. It is first ball is black means in the urn there are 5 red and 7 black balls. So the probability is 5 out of 12. Is this clear? So probability, now we have to find probability of A. We are applying the theorem of total probability. Probability of A is equal to probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. We can substitute the values. You know that E1 is 1 by 2 into A given E1 is 7 by 12 plus probability of E2 is 1 by 2 into 5 by 12. Find out the answer. So the answer is equal to 1 by 2. Okay, first we have to identify what is E1, what is E2 and what is A. Okay, now the next one is Bayes theorem. Next heading, Bayes theorem. Write the statement: if E1, E2, etc. En are n non-empty events which constitute a partition of the sample space S, which constitute a partition of the sample space S, and A is any event associated with S of non-zero probability then probability of EI given A, probability of EI given A is equal to probability of EI into probability of A given EI divided by sigma j equals 1 to n probability of EJ into probability of A given EJ. This is Bayes theorem. See, from the previous example, you know how to find the events E1, E2, etc. En and how to find their probability, and then probability of A given EI, you know how to find this. This is the possible outcomes favorable to the event EI divided by total number of possible outcomes or the total probability. The basic definition of probability we are applying here. Number of favorable outcomes divided by total number of possible outcomes. So instead of that, we are applying probability in this. Probability of EI, probability of EI given A we have to find. So if you have to find E1 given A, probability of E1 into probability of A given E1 divided by the total probability. This is Bayes' theorem. While doing problems, it will be clear to you. Okay, just have the statement now. Probability of EI given A. This is equal to probability of EI into probability of A given EI divided by total probability sigma j equals 1 to n probability of EJ into probability of A given EJ. So let us have a question. A bag contains 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the 2 bags is selected at random and a ball is drawn from the bag which is found to be red. Find the probability that the ball is drawn from the first bag. See, while getting such a question, first you have to identify what is E1, what is E2, what is A, and what about their probabilities. So for that, first see in the question, a bag contains 4 red and 4 black balls. Another bag contains 2 red and 6 balls. That means 2 different bags are there. So let us write bag 1 and bag 2. So for a person, there are 2 possibilities here. Either you can choose bag 1 or you can choose bag 2. Okay, there are 2 different bags, bag 1 and bag 2. So a person can choose either bag 1 or bag 2. What is the probability of choosing bag 1? 2 bags are given to you. Choosing a bag from it is, what is the probability of this bag 1 getting bag 1? We are not concerned about the red balls or black balls inside it. 2 bags are given to you and out of that you have to choose one. So it is 1 by 2. See now, this choosing bag 1 is to be the first event and choosing bag 2 is the second event. Is this clear? Okay, so you have to write down the events. E1 is choosing bag 1. Then E2 is choosing bag 2. So along with this, you can write probability of E1 is 1 by 2 and probability of E2 is 1 by 2. So you can always verify whether this is correct or not. Add these two, you will get always equal to 1. Probability of E1 plus E2, that will be equal to 1. The sum of the probabilities of E1 and E2, probability of E1 plus probability of E2 is always equal to 1. Up to this, is it clear? Okay, now probability of E1 is equal to 1 by 2 and probability of E2 is equal to 1 by 2. Now see, the first bag contains 4 red and 4 black balls. So here in this bag 4 red balls and 4 black balls. And in the second bag 2 red balls and 6 black balls. See, in the first bag 4 red and 4 black balls. In the second bag 2 red and 2 black balls. 6 black balls. Now we have to identify what is A. What is the event A? See the second part of this. One of the 2 bags is selected at random and a ball is drawn from the bag. So the first part is choosing a bag. Then a ball is drawn at random from the bag, and which is found to be red. Which is found to be red. It is given. It is a given condition. That given condition is to be considered as the event A. A is the ball drawn is red. What is the known condition that is to be taken as the event A? Okay, A is the event, the ball drawn is red. Now, if we are choosing the first bag, what is the probability of getting a red ball? Probability of getting a red ball. A means getting a red ball. So, probability of getting a red ball when the first bag is taken. What will be the probability? From this you can write A given E1. It is 4 red ball, 4 black balls, so total 8, and the probability of getting it is 4 by 8, which is equal to 1 by 2. Okay, similarly we can find probability of getting a red ball when the second bag is taken. It is equal to, see, 2 red balls and the total number of balls is 8. So it is 2 by 8, which is equal to 1 by 4. Is this clear? Okay. Now, see, now we got probability of E1 as 1 by 2, probability of E2 as 1 by 2. So you know what is the event A, what is probability of A given E1, probability of A given E2. All these are symbols. You can read this as probability of getting a red ball when the first ball bag is chosen, probability of getting a red ball when the second bag is chosen. Okay, now this last part of the question is find the probability that the ball is drawn from the first bag. That is, we have to find probability of first bag. Probability of getting first bag is E1 given the ball is red. So you have to find probability of choosing the first ball when we know that the ball drawn is red. Okay, so it is probability of E1 given A is equal to, by Bayes theorem, we can write this as, this is equal to probability of E1 into probability of A given E1 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. In the denominator we are taking the sum, and in the numerator the favorable outcome. That is, here we need E1, so it is probability of E1 into probability of A given E1 divided by denominator is the total probability. Apply the values here. Probability of E1 is 1 by 2 into probability of A given E1 is 1 by 2 divided by 1 by 2 into 1 by 2 plus probability of E2 is 1 by 2 into A given E2 is 1 by 4. Simplify this and find the answer. Okay, the answer is 2 by 3. I hope you got an idea how to apply this Bayes theorem. Okay, first try to draw a figure like this, then it will be easy for you to identify E1, E2, A, then their probabilities and all. Okay, one more question. of the students in a college, it is known that 60% reside in hostel and 40% are day scholars. Previous year results report that 30% of the students who reside in hostel attain A grade and 20% of day scholars attain A grade in their annual examination. At the end of the year, one student is chosen at random from the college and he has an A grade. What is the probability that the student is a hostelier? Of the students in a college, there are two different sets. 60% of the students reside in hostel and 40% are day scholars. So can you identify what is E1 and E2? We are considering a group of students and that group of students are classified into two different groups. The first one is residing in hostel and the second group is day scholars. Okay, so the first event is to be taken as students residing in hostel. Can you give the probability of E1? What about the probability of E1 here? 60% reside in hostel. So the probability can be taken as 60 by 100. Number of students residing in hostel divided by total. Total is to be taken as 100 here because 60%. Then E2 is students who are day scholars. So what about the probability of E2? What is probability of E2? It is 40 by 100. Is this clear now? You got E1 and E2 and their probabilities. Now you have to identify the event A. What is the event A? What is the known condition here? Previous year results report that 30% of the students who reside in hostel attain A grade and 20% of day scholars attain A grade in their annual examination. At the end of the year, one student is chosen at random from the college and he has an A grade. This is known to us. It is a known condition. When a student is chosen at random, he has an A grade. That is the known condition to us or the known result to us. So it is A is getting an A grade. So here two possibilities are there: getting an A grade, not getting an A grade. Here also that two possibilities are there. So A is getting an A grade. Now we have to get probability of getting an A grade when the student is residing in hostel. Probability of getting an A grade when the student is residing in hostel. What is the probability? How it is 1 by 2? Read the question. Read the question well. Read the question. These are the students residing in hostel. And here it is given that previous year results report that 30% of the students who reside in hostel attains A grade. So here it is 30% of the students get A grade and the remaining 70 not getting A grade. So what is the probability that getting an A grade when the student is residing in hostel? It is 30 by 100. Okay. Is it clear now? Okay, now the next one is probability of getting an A grade when the student is a day scholar. Probability of getting an A grade when the student is a day scholar. Okay, it is 20 by 100. It is 20 by 100. It is given that 20% of the day scholars are getting A grade and the remaining 80% are not getting A grade. I hope this part is clear to you. Now the question is, what is the probability that the student is a hostlier? The student is a hostlier. That is probability of, what you have to find? Probability of the student is a hostlier. What is the symbol for this? Probability of, okay, E1 and a condition is given to us, and that is A. Probability of E1 given A is equal to probability of E1 into probability of A given E1 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Substitute the values and find the answer. Okay, it is 9 by 13. On simplifying, you will get this as, see, here also we can verify it. Probability of E1 plus E2 is 60 plus 40, 100 by 100, it is 1. Probability of E1 plus probability of E2. See, now we can do one more. Just to read the question, fourth question from the textbook. In answering a question on a multiple choice test, so when you are getting a multiple choice test, a student either knows the answer or guesses. So what is E1 and what is E2? What is E1? See the first part. In answering a question on a multiple choice test, a student either knows the answer or guesses. So we can write E1 as knows the answer and the second one is he guesses the answer. So E1 student knows the answer and E2 student guesses the answer. What is the probability of E1 and probability of E2? Read the question, it is given in the question. Let 3 by 4 be the probability that he knows the answer and 1 by 4 be the probability that he guesses. It is directly given in the question. Probability that he knows the answer is 3 by 4 and probability that he guesses the answer is 1 by 4. See now, when he knows the answer, it will be correct. If the student knows the answer, it will be correct. If he guesses the answer, there are two possibilities. The answer may be correct or that may be incorrect. Okay, or it is wrong. So there are, if he knows the answer, only one possibility is there, the answer is correct, answer will be correct. And if he guesses, there are two different possibilities that may be correct or wrong. What is the event A? From the question you have to identify what is the event A. In the question, it will be given that or found to be. That is the condition known to us. That is to be taken as the event A. So what is A? What is the probability that student knows the answer given that he answered it correctly? Given that or found to be. So what is to be taken as A? A is, the answer is correct. Answer is correct. That is the event A. Now we have to write the probability of when the answer is correct. Answer is correct when he knows the answer. What is the probability? Probability of the answer is correct when he knows it. When he knows it. What's the probability here? This is a certain event or a sure event. When he knows the answer will be correct. So what is the probability? It is a certain event or a sure event. If the student knows the answer will be correct. They just listen to this. See, here it is. If the student knows the answer, it will be correct. No other option is there. It is a sure event. Sure event means the probability is equal to 1. Okay. Probability of A given E1 is equal to 1. Now what about the probability of the answer is correct when he guesses? You have to read the question well. See, a part is left here. Assuming that a student who guesses at the answer will be correct with probability 1 by 4. So if he guesses, the answer will be correct with probability. The answer will be correct if he guesses the answer with probability 1 by 4. It is given in the question. Okay, so this is equal. All the requirements are here. Now the question is, what is the probability that the student knows the answer? What is the probability that the student knows the answer? So it is probability of E1 given A. This is equal to probability of E1 into probability of A given E1 by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Apply the values, find the answer. Okay, it is 12 by 30. Right. Substituting the values, you will get the answer as 12 by 30. You have to practice more questions. Let us do the remaining questions in the next class. Okay. Thank you for joining.